how to find the point of intersection of two lines. Okay. How to find the point of intersection of not two lines actually. This is not two lines. Point of intersection of lines means three lines actually. We must have at least three lines or two lines also we can find. Okay. Between two lines. Find the point of intersection of two lines. If three lines are intersecting at a point, they are called point of congruency. That is called point of congruency. So here what we will do, we will equate the two lines. The procedure you can understand, equating and then solving the equating and getting the three equations. I'll take one question, then you will understand better. Find the point of intersection of lines vector r is equal to I plus j I plus j minus k plus lambda times 3i minus j, and second line is vector r is equal to 4i minus k plus mu times 2i plus 3k. Show that they are intersecting each other and find the point of intersection. Find the point of intersection, and before that show that they are intersecting line also. If we have to show that also, show that they are intersecting. These are intersecting lines. So point of intersection, how to find the point of intersection and how to show that they are intersecting lines. We will equate them because this is representing vector r, this is also representing vector r. So we will equate these two intersecting lines. So we can write as, we can say that these lines will intersect if and only if they are equal. Means I plus j minus k plus their vector equations are same. For I minus k plus mu times 2i plus 3k. Now you can write the coefficients of I 1 plus 3 lambda I, and j is also 1 plus 3 lambda. No. J is minus 1. So 1 minus lambda j, because this is j and this is j. 1 minus lambda j and minus k. So there is no k here. Similarly here I is here, I is here. So 4 plus 4 plus 2 mu I j. Where is j? No, there is no j. There is no j this side. So for your convenience, you can write 0j because you have to equate the coefficient. Then k minus 1 plus 3 mu k cap. Now collecting the like terms or equating the coefficients of I, j, k separately. Equating coefficients of I, j and k separately. So I is 1 plus 3 lambda, first equation. 1 plus 3 lambda will be equal to 4 plus 2 mu. Second, j is 1 minus lambda is equal to 0. And third is minus 1 is equal to minus 1 plus 3 mu. Okay. So if they are intersecting, we will find the value of lambda and mu from any two equations and put in the third equation. If it will satisfy, then we can say they are intersecting lines. Equation number 1, suppose this is equation number 2, this is equation number 2, equation number 3. So in equation number 2, if you will solve it, we get lambda is equal to 1. This also you are getting mu is equal to 0. Mu is equal to 0. So when you put mu and lambda in equation 1, if it's satisfied, then that means they are intersecting lines. Put in first, so 1 plus 3 lambda means 1 is equal to right hand side 4 plus 2 mu 0. So that is equal to 4 is equal to 4. This satisfies. Therefore, these are intersecting lines. These are intersecting lines. So for intersecting lines, we have to do like this. Now, point of intersection. What will be the point of intersection? So in any equation, first equation, we will put lambda is equal to 1. If you put lambda is equal to 1 in equation number 1. So we get vector r is equal to I plus j minus k plus 3I minus j plus 0k. Now solve this. We get 3 plus 1 4I minus j plus j 0j plus 0j and minus k. So therefore the point of intersection is 4 0 minus 1. Therefore their point of intersection is 4 0 minus 1. So if you have to find the point of intersection, find the value of lambda or mu. Anyone you can put. If you will put mu also, you will get the same answer. Mu 0, that means you will get 4i minus k. This is also 4i minus k. So either mu or lambda, you can put anyone, and that vector will give you the point of intersection of two lines. Shortest distance between two lines. As we have seen, two lines are intersecting lines. If they are intersecting lines, if the lines are intersecting lines, if they are intersecting lines, what will be the shortest distance? Intersecting lines. For intersecting lines, shortest distance between them is 0 because they are intersecting. Second thing is parallel lines. If two lines are parallel, for parallel lines, suppose we have two parallel lines. This is one line and another line is, this is one line and another line is parallel to this line. We have to find the distance between these two lines. So what will be the distance between these two lines? Shortest distance is perpendicular. If we draw perpendicular from one point, this perpendicular from this to this will be the shortest distance. This will give you the shortest distance. So this is perpendicular and shortest distance. HD used to say SD, and we can take SD this also. And this line, this is L1 line, this is L2 line, and you know that its equation is vector R is equal to A1 vector A1 plus lambda vector B1, and its equation is vector R A2 vector plus mu B2 vector. Then the shortest distance formula is, for parallel lines, shortest distance, or we used to denote by small d also, small d, is equal to modulus of vector B cross product with the difference of A2 minus A1. Here A1, A2 will be used. A2 minus A1 and divided by magnitude of B. Okay. A2 minus A1 for parallel lines. And now for intersecting lines 0, for parallel lines this one, and for skew lines. Yes, Sharif. this is not B. Yes. Yes, correct. This is actually when they are parallel, this B1 and B2 will be equal. B1 will be equal to B2, vector B1 will be equal to vector B2, and this will be vector B when they are parallel lines. Okay, so that's why we are using only B, Sharif. Got it? Yes, for parallel lines, B1 is equal to B2. So we used to write only B here. We should write B. This is also B. So B1, B2 is equal to B for parallel lines. So no need to write 1 and 2 here. Okay. Now for Q lines, the shortest distance is, they are skewed lines, neither parallel nor intersecting. Therefore, the shortest distance can be calculated by this formula, modulus of absolute value of A2 minus A1 vector with the dot product of B1 cross B2. B1 cross B2, and this whole divided by the magnitude of B1 cross B2. Here the lines are skewed lines. So that is line 1 for a skewed line. Line 1 will be A1 vector R is equal to A1 plus lambda times vector B1. And for line L2, vector R is equal to, L2 is represented by A2 plus mu times B2 vector. Then the shortest distance we can find by this way. Okay, got it. In Cartesian form, this will become a very big, huge formula for Cartesian form for finding the shortest distance between two lines. In the Cartesian form, the same formula will be reduced to, yeah, we have to take another. In Cartesian form, shortest distance, I'm talking about skew lines. Shortest distance formula will be equal to determinant x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2. This determinant divided by under root, the thing that you have used for sine theta, b1 c2, b1 starting b1 c2 minus b2 c1 whole square plus c1 a2 c1 a2 minus c2 a1 whole square plus A1 B2 minus A2 B1 whole square. A2 B1 whole square. This is the shortest distance. So we have to find determinant and then we can put the lines will be, you know that L1 in the Cartesian form, the L1 line will be in the form of x minus x1 upon A1, y minus y1 upon B1 and z minus z1 upon C1, and line L2 will be x minus x2 upon A2, y minus y1 upon y minus y2 upon B2, and z minus z2 upon C2. Perpendicular distance of a line from a given point. That is also left. Perpendicular distance of a line from a given point. Okay. So perpendicular distance of a line from a given point. Vector form, in vector form, P is a point and from here you have to find the perpendicular distance up to this line. AB, this is AB line, and PL, this is PL. L is the foot of perpendicular from the P on the line, and the position vector of L. What will be the position vector of L? So position vector of L, that is OL, will be equal to A plus lambda B. That is OL. You can say the position vector of L will be OL. And what will be the value of PL? So then vector PL will be equal to OL minus OP. So A plus lambda B minus vector alpha. This point is denoted by alpha vector. So we got A minus alpha plus lambda B. This is vector PL. And this is AB. The vector of AB is vector B. So they are perpendicular to each other. So therefore, we can say that PL dot vector B will be equal to 0. So find their dot product. PL is A minus alpha vector plus lambda B vector with dot product of B is equal to 0, and solve it. We will get B dot A minus alpha plus lambda into B dot B, that is B square. So lambda will be equal to P dot B means magnitude of B square. So magnitude of B square will come down, and here you will get A minus alpha vector A minus vector alpha dot vector B. So on substituting the value of lambda in A plus lambda B here and PL here, we obtain the position vectors of L and PL. Okay, and the magnitude of PL will be the shortest distance. So now this value put in this equation number 1, equation number 2, 2 and 1, we get value of PL. So magnitude of PL will be the shortest or distance from the point to the line, distance of AB from P. This will be the working rule. We will do the question, you can understand better. And Cartesian form also we can do it instead of this one, we can take the Cartesian form. Then also the same way we have to do. So we have to find the foot of perpendicular. Okay, so that's all. For this one we can start the exercise, but one question I will do, then next time we will start the exercise. Question is, find the coordinates of the foot of perpendicular. Now foot of perpendicular, if we know how to find the foot of perpendicular, we can find the distance also. So the question is, find coordinates of foot of perpendicular drawn from A184 to line joining points B, whose coordinates are 0, -1, 3, and C, whose coordinates are 2, -3, and -1. So this is BC, and this is from A to B. So A is this point whose coordinates are 1, 8, and 4, and BC is the line 0, -1, 3, and C is 2, -3, -1. Find AD. Find A, foot of perpendicular D. Find the foot of perpendicular D. Therefore, equation of line BC say it is equal to lambda. Okay. Now equating them each one, so x is equal to 2, 2, 2, 4. So you can write here 2 ones are 2, 2 ones are 2, 2 twos are 4. Then equate to lambda. So x will be equal to lambda, y will be equal to minus lambda minus 1, z will be equal to minus lambda plus 3. So coordinates of D will be equal to so this is the coordinates of lambda D for some value of lambda. Okay, but AD is perpendicular to this one. So you can find the direction cosines of AD and direction cosines of BC. Direction cosines of BC are 1, 1 minus 1 minus 2, 1 minus 1 minus 2.